Good afternoon, everybody, and welcome to the second Green IT Specialist Group fireside chat, but we've updated it because it's the summer, so now it's a fire pit chat. We're all outside drinking a glass of wine, having a glass of beer. Between myself, John Booth, the Green IT's Vice Chair, and Jonathan Evans from Total Datacenter Solutions. We're going to be talking in the main around sustainable and energy smart data centers and green stuff, but this is part of the London Climate Action Week, which you can find more information about on londonclimateactionweek.org. And there is also an event on the 30th of June, which is how membership organisations, no, that's not the wrong one, forget that one. I'll come back to that later on. So John, would you like to introduce yourself while I grab this correct URL for the event?
Yeah, sure. Hi, good afternoon, everyone, and thank you for joining us today. I'm Jonathan Evans from Total Datacenter Solutions. I started the company 20 years ago. Prior to that, I was designing computer rooms for 3090 IBM machines and the like, when they were water cooled, of course. And then every large company and every large enterprise had its own computer room. And from there, then I started in 2002, Total Data Center Solutions, specializing in co-location startups. So we first worked in Dublin with a big data center, new data center there, where they were looking to try and get the thing off the ground. And I began to understand all the issues around starting a co-location data center, how to get yourself a reputation as being a good quality data center that didn't fall over, and how to bring clients into the data center. And ever since then, I've specialized in that aspect of the business. So I did work in Dublin for 3 years. Then I went to work in London with a co-location company working around the M25, building new data centers. And those data centers were built specifically for the banking industry, where they were coming out of Docklands because of the risk of security aspects. So they came out of Docklands and they came into our data centers around the M25, and connectivity was the key to that because they had to be close to the trading desks in the city of London. That company was sold up, and I then moved on to Norway, and that's when my life changed a little bit, because instead of being on the technical side of things, I worked for Green Mountain Data Center. And Green Mountain was the first data center which I really could call a sustainable data center. It was built in a very picturesque location on the side of a fjord in Stavanger, and they used an old NATO bunker to actually create the data center. So that was the first sustainable tick in the box, the fact they used an existing building. The next tick in the box was the fact that it was powered by hydroelectricity from 3 different hydroelectric power stations. And then the third thing was the fact they used the fjord water to actually cool the data center. They brought the water up from the bottom of the data center, of the fjord, through a hyphonic process, and then they ran it through a stainless steel heat exchanger, and then they pumped the cold water around the data center. And that was absolutely zero carbon emissions, in terms of the fact that all they needed was a couple of pumps to circulate the water. So from then I went to work in Luxembourg for Lux Connect, working with them with their co-location data centers, which were not sustainable as such because they didn't have green energy, but they were buying renewable energy certificates, but enough of that later. And they did have a plant next to them, a tri-generation plant, which ran on wood pellets or wood chips, and created hot water, electricity, and chilled water. And that was called Kilowatt, and that was a very interesting development of that plant, but it cost 10 million to build. So it wasn't the sort of thing that everybody can do. From there on, I went to work with EcoDataCenter and another company, Nodepol in the Nordics. Again, enough of that. I'll tell you a bit more about that later. So EcoDataCenter is the climate positive data center in Sweden. And I work with those guys now, and I also do other things around technology, like immersion cooling and battery storage. So that's the portfolio of work for TDCS at the moment, and that's where we are.
Thank you, John. Very good. I put the event information for next Wednesday on the board, so you're probably seeing that now. It's climate, environment, sustainability, key issues for the UK tech sector, and that is including Suzanne Baker, who's the Associate Director for Climate, Environment and Sustainability from Tech UK, and there is somebody else who I can't seem to see on that list. Never mind. Anyway, John, thank you for that introduction into your life, and we've known each other for many years, haven't we? We've had a few scoops together. Okay, so just to so we finished a sustainability benchmarking exercise for a French data center company over Christmas and New Year, and one of our briefs from them was to actually define what sustainability is, and we basically searched the globe looking for information about sustainable data centers, what the definition was, and we couldn't find any. We absolutely couldn't find any at all that were recognized by our peers in the industry. And indeed, if you speak to some of our colleagues on the standards committees and in other areas such as the infrastructure masons and the BSI, there is no globally recognized definition for data center sustainability. And I think it's an interesting question, because there are a lot of data centers out there that are citing sustainability credentials, and of course they're all doing it differently. So what's your definition of sustainability in the data center market? What do you think are the key factors?
I think a sustainable data center is one that genuinely has no negative impact or potentially a positive impact on the global carbon footprint. And I can cite EcoDataCenter as an example of that in Sweden. I can explain more about it later, but many data centers, as you say they are green or sustainable, but run on dirty power or renewable energy certificates. And these are now considered of low quality. And products have not got the credibility that they used to have, because they don't actually run on genuine green energy. And many of the German data centers are doing that and buying Norwegian electrons and expecting them to pop up in their German data centers. So I think it needs to have no impact on the environment, really. That's the most important aspect of it, or possibly, as in EcoDataCenter's case, a positive impact on the environment.
Very good. Okay, so given that lack of definition and the problems that are potentially going to arise from data centers citing a multitude of different environmental factors, signing up to different power purchase agreements and getting reported by different sustainable methodologies, do you think that the standards development organisations such as something like ETSI and the International Telecoms Union and maybe the ISO, should they begin to collaborate on truly unifying the definition of a sustainable data center?
Well, yeah, they certainly should. It would be a great step forward, isn't it? It's just one of those things that's really difficult to implement, because up until now, we've got this new allegiance of data centers now, alliance of data centers, which are trying to reduce the carbon footprint in Europe. But up until now, there's not been a real central voice who can coordinate all of that type of activity. But it would be great if they could have define a sustainable data center, and then benchmark it as well, so everybody understood where they are in terms of how green a data center actually was.
Yes, and that pact that you're referring to is actually the Climate Neutral Data Center Pact.
Yeah.
And I understand that they've recently been over to Brussels and presented some proposals to the Commission for analysis. And we will wait and see what comes back. Of course, there is the EU Code of Conduct for Data Center Energy Efficiency, which is a long-standing series of best practices that can make your data center more energy efficient and sustainable. And I believe that there will be a more formal link between the Climate Neutral Data Center Pact and the EU Code of Conduct moving forward. I know that we have actually been having some behind the scenes discussions to that end, so hopefully that will bear fruit. Now, it's interesting because obviously the EU Green Deal is the central plank for the creation of the Climate Neutral Data Center Pact. And I think it was back in February 2020 when they basically announced that data centers can and should be carbon neutral by 2030, and that this put a bit of panic into the sector, which is why they created the Climate Neutral Data Center Pact. But and I don't know if I can say this, but anyway, how should that manifest itself? The Climate Neutral Data Centers Pact is a self-regulatory initiative, and they've announced some targets, and it'll be interesting to see what the commissioners say. But what do you think there should be a central EU Directorate General responsible for policing carbon neutrality by the virtue of mandatory reporting, and should that apply to enterprise data centers as well?
Yeah, I think why not enterprise data centers as well? There's no reason why they shouldn't be included in this path. And I think it may have to be legislation in the end, because at the end of the day, co-location data centers are commercial organizations, and they have to report back to their shareholders and investors. And so they're not going to spend money unless they're really compelled to do so. And some of the things they're going to have to do are going to cost significant amounts of money. So I think they're going to push the boundaries as far as they can. And then when they have to, by legislation, they will start to invest large amounts of money. An example would be Lux Connect, where the tri-generation plant I was referring to there, in order to get that data center climate negative or neutral, was costing, as I said, over 10 million. And so because it was owned by the government in Luxembourg, they were able to invest that amount of money. But most co-location data centers will not spend that money unless they're compelled to do so. And that's, I think, the bottom line. So I think there may be a little bit of legislative push required to shove them over the edge.
Absolutely. And for those that don't know, an enterprise class data center is one that is owned and operated by one organization for itself. And a co-location data center is a commercial operation where it may have multiple customers in, providing services, as I said, to multiple customers. So that's kind of difference there. And how do you feel about the EU providing assistance to legacy facilities to help them improve if they do bring in some sort of mandatory reporting and self-regulation in order to meet the Climate Neutral Data Centers Pact targets?
I think the EU regulations would stop them doing that because they're not allowed to help companies, are they? It's very, very difficult for them to help organizations with grants and that type of thing, because they become non-competitive then. So I guess it wouldn't be a bad thing for them to subsidize it, but it would be very, very difficult to do, I think, under EU regulations. I may be wrong, I don't know enough about EU regulations, but I know whenever EU gets involved in trying to subsidize an industry, they always have issues around competitiveness. There's no harm in it if they can do it, because it would obviously have beneficial effects in the long term. And they could do it by investing in something on a payback, because they would reduce the energy cost of running the data center. They could, instead of giving them money, they could just lend them money and then pay it back over a period of 10 years because of the amount of savings that we made in the energy costs. Forward for them.
I would tend to agree with you, but of course we're not in the EU anymore, so we wouldn't be bound by that any EU directives here in the UK. But we wait to see what the UK government comes out with. I know that there were some changes to the Energy Act impending, and of course the Climate Change Act. But what was interesting, I think it was last week or the week before, was that PPN 0621 was released. So, and what that says basically is that any company providing services for government needs to have a carbon reduction plan, and it will be reviewed for any bid or tender that comes into play as of the 6th of June. And that has to include data centers and basically providing organized services to not only central government, but also local government and any body that's publicly funded. So I think there's a big shake-up coming with that coming, and there'll be a lot of smaller organizations that will be required to provide climate reduction plans. That's probably a topic for another day, though. So, John, your recent project is the EcoDataCenter in Falun in Sweden, and I've been tracking this actually for probably about 3 years now, because I remember meeting up with some of the guys from the EcoDataCenter before the thing had even been built at a high performance compute conference in London in 2019 or 2018. So what's special about your project over there then?
I think it began with the site selection. You know, the key to it was site selection, because one of the biggest issues around being able to use the waste heat from servers is finding something to do with it. So the site selection had 3 main focuses. The first one was the fact that the power to the site was actually hydro and wind power, not atomic power, and that's number 1. And it also had diverse feeds, of course, and largely, I think it's got about 80 megawatts of potential supply available there. So that's number 1. Number 2 was the fact that it was next to a wood pellet manufacturing plant, and the wood pellet manufacturing plant could be used. They could use the waste heat from the servers to dry the wood during the process of turning the wood into wood pellets. And then when you've got the wood pellets, of course, you use that to generate electricity or generate energy. So that's another climate positive aspect to it. The next thing was the fact that they were able to use the waste heat for the local town, for the local district heating system. And that was obviously just down to the fact of where it was located. And another of the big data center co-location companies in the Nordics, Green Mountain, where I worked with years ago, they've really struggled to find something to use all the waste heat for because of their remoteness. One was on an island and the other one was in a valley with not many people. And they've now actually found a solution. They found solutions in fish farming and in lobster rearing. So good luck to them with that. So
absolutely, I was reading about those last week, and I think that's an excellent use of. So
that was one of the aspects, and the last aspect, which was one which is caused less controversy than I thought it would, and that is the fact they built the data center in wood. Now they built it in a very special wood. It's called Prolam, and it's laminated wood, which is created under high pressure. It's created under such high pressure that it cannot burn apart from a carbon layer on the outside of it, and therefore it's structurally much more sustainable than steel and concrete in a very intense fire, because the structure of the wood does not change, unlike concrete and steel. Steel can buckle and concrete can disintegrate. So it's made of wood, and one of the great statistics about it is the fact that the amount of wood they use to build the data center can be replaced in the forest of Sweden in 5 minutes of growth. And that's what they tell me. I don't know how true it is, but that's what they say. So that is a really interesting aspect of the data center design, and I think it might be unique. There might be one more up in the north of Sweden, I think. But apart from that, no one else has built a data center in wood. I've written some articles about it and published them, and no one has really come back to me with any really negative reactions to it, surprisingly enough, considering we're such a risk-averse industry. But in the articles, of course, I could show examples like airport lounges, huge airport lounges, which are built of wood as well, of the same material. So, and obviously no airports are very, very risk-averse. And so I think I was able to convince people with the examples that we had that the wood construction was a safe construction method. And it does actually have an embedded carbon in it. So by the time you've worked out all these different calculations, you actually find that the amount of power that's consumed and the amount of energy that's consumed and the amount of construction method, it does actually can be calculated to be climate positive. And there are, on the EcoDataCenter website, there are calculations which illustrate the fact that it is a climate positive data center. And I think that's one of the first co-location data centers to have their calculations on a website like that to be examined by other people to illustrate the fact that it's climate positive. And I think that's a great example to set for others.
And I would completely agree. In fact, the 13th edition of the EU Code of Conduct will change the life cycle assessment best practice from optional to mandatory. So I think that's going to be quite interesting for all of the applications that are coming up for renewal or new applications, is that they're going to have to demonstrate that they have done a life cycle assessment. And I think that's brilliant. Yeah, we mentioned the EcoDataCenter actually in our sustainability report to our client, and they were very resistant to begin with. They basically said, no, we're not having a wooden structure. It's just not going to happen. And I believe that one of the senior people had actually been over there and had asked a question of that, and we still had a bit of reluctance. But we basically said, look, you know, we know your reluctance, but we've looked at the actual underlying science behind it in terms of fire protection. And compared to conventional wooden structures and other building techniques, this glulam or prolam laminated wood is actually, you know, it has better fire protection properties than even steel. Steel tends to basically reach a certain point and then just collapse, whereas wood will stay there and it will char on the outside, but you'll still maintain the structural integrity of the beam. So it's all good stuff on that point of view. We do have a question, and I'm just going to check it. Yes, we can. I've got a training course set up for a climate reduction report, actually, Margaret, that we're actually going to create a training course on calculating your carbon footprints for ICT, which is an extension to our Green IT fundamentals course that we're planning to run in Q4, which talks about Green IT stuff. Anyway, so John, we're going back to EcoDataCenter. You said those calculations. Have you calculated the embodied energy of all the construction components, the concrete floor, the wooden frame, the electromechanical equipment, heat pumps, pipework, roofing materials, etc.?
Yes, they have actually. They went into a great deal of detail, and they've even included the emissions from testing the generators every month in the calculation. So they've gone into a lot of detail in that regard.
And that's great. And I think that's something that the whole industry is going to have to start to think about moving forward. It is, you know, I've gone on record in a number of webinars recently saying that the industry seems to be a bit behind in coming forward about its sustainability. I think the main issue is that obviously EcoDataCenter is one data center with a number of smaller co-location sites which have been purchased through acquisition. But some of the big global players, they just got cookie cutter designs, and they just basically lift their designs from the States and then they try and drop them into Asia Pac and Europe and Latin America. And it takes a long, they're like super tankers, aren't they? It takes a long time to get the design mantra changed. And of course they're also trying to be all things to all people. So with a varying kind of education of customers, they have difficulty. They're trying to be one size fits all, and I think they might have to change their view on that moving forward. And one of the ways of doing it, of course, is to educate their customers. Because that, you know, I've heard stories of people who come into data centers, go, right, we want 18 to 21 and 50% plus or minus 5 humidity levels on SLAs, and you just got to turn around to them and say, look, mate, you know, we're in the 21st century now. We're not in the 20th. So those old IBM Green Book temperature ranges are really not cutting the mustard. And of course, even if you look at ASHRAE, we've got 18 to 27 as a recommended. And actually, it's even wider for an allowable, which is 10 to 35. And if people look at their servers and get the operation manual out and see what operating temperatures there is allowed, it's 10 to 35, and you derate them in altitude. And, you know, the derating of altitude is 300, I think it's 1 degree for every 305 meters. You know, I don't think there's anywhere in the UK. I think the highest city is only at around 600 feet. So there's no excuse not to look at those wider temperatures.
Yeah, you'd have to consider the fact that people have to work in these rooms, John, as well.
Well, I don't know if they, you know, there's a best practice that says that data centers should be completely only working in there on sporadic occasions. So, you know, they don't need to go in there. And I was reading today about somebody that's looking at some alternating, using robotics and AI in the data center, which would negate the need to have people in there. But I think for the few instances where you'd have to go into a hot corridor and do some work, most of the equipment now can be accessed from the front, so there's really no need to go behind. But of course, that's moving into a different thing, basically. Right. Where are we? Okay, yes. So LCAs we've covered. Yeah, I'm going to skip that question, John, and go to energy. So many commentators have a different view on the use of renewable energy for data centers. Some even go as far to say that why just data centers? Why not other public buildings such as hospitals, healthcare centers, government buildings, and schools, etc.? So what's your view on that in terms of renewable energy for them?
Yeah, well, at the moment, our company is promoting a solar solution combined with a very large battery solution, multi-megawatt lithium-ion batteries. And we are actually installing those in hospitals, and we're using CHP plant combined with it as well in order to reduce the carbon footprint of the hospital. And that doesn't cost the hospital anything. It's done on a shared savings basis, and the same with data centers. So we install the batteries, we operate it, we maintain it, and we install the solar panels and wind turbines possibly, and then we reduce the carbon footprint that way. And it costs the hospital or the data center nothing to do that. All we need to do is find some space for the containers. And it's astonishing now, you can get 3 megawatts for 1 hour out of a 40-foot container or 12.2 meter container, which is an extraordinary statistic when you think about it. 3 megawatts, which is enough to run a small town in a 40-foot container. Yeah, so yeah, definitely we're going towards trying to help organizations outside of data centers to reduce their carbon footprint with these strategies that we're offering. And that's one way of doing it. And obviously, the other aspect of that is you can tie it into some sort of microgrid solution. So where you can actually run something, the primary source of power would be solar, which is what Switch have done in the States. They've got massive solar farm fields in the States, which are big enough to run the data center. And then they're putting them into Tesla batteries. And they're running their data center from the solar farm, I think. Well, that's their plan for the future anyway. I think it's about 40 megawatts of solar. But of course, you need a desert alongside your data center to do that, and not everybody has a desert, which is the downside to very large solar arrays. So yeah, it's that's one solution for data centers which have the space around them, but not for data centers in the city center.
Yeah, and I recently worked on the Catalyst project, which was an EU-funded project that was looking at precisely that. That was using renewable energy systems locally and remotely, actually, and also the waste heat reuse, as we discussed earlier with the fish farms. And there are other ways you can do it, such as urban farming or heating swimming pools. What else? Oh yeah, district heating system, obviously. And to be honest, John, that's fine in the northern part of the Europe and potentially Scotland, but in the south, and like for instance Spain, Portugal, Greece, etc., that it's a problem with using waste heat into district heating systems, because they don't really need much heat in the summer, and they don't really need much heat in the winter either. So do you think that could be kind of retrofitted to provide a district hot water system, some description?
Yeah, I mean, the difficulty of reusing the heat from the servers is a big one, because the heat that's coming off is not high quality heat, it's very low grade heat, and there's not much you can do with it. And so you often have to put a heat pump solution in there to lift the temperature a little bit of that hot water to make it usable. The tri-generation plant at Kiowat, they had these chillers which ran off hot water. You might be able to explain that better than I can, but they actually use hot water to create chilled water for the data center. Another solution I've seen is if you can get the temperatures up high enough, you can use it to actually generate electricity from a little module that I've come across recently. And that's where, going on to my other solution, which is immersion cooling, that solution is much more efficient at capturing the heat from the servers. and the temperature that comes off that is a much higher temperature. It's about 60 or 70 degrees C, I think. So it's much more usable than the water you get off a solution which is air cooled.
Yep, I would completely agree with you, John. And you know, I think immersed compute solutions are slowly but surely gaining credence. I remember writing an article for Data Center Solutions magazine in 2016, I think, and I said then that it was one to watch, and it has most definitely gone. It's exploded. You know, there are more solutions than ever that are exhibited at all of the events that we used to go to, and I know that Asperitas are doing some good work in the Netherlands, providing immersed compute on edge solutions at Shell petrol stations, and they won a competition, Shell's Kickstart or Springboard competition, and as a result of that, they've been given. So they're installing these 5G type edge solutions in petrol stations. And not to forget our very own Isotope based in Sheffield, which is on the high technology park up there just before you get into the city centre. They've got an interesting vertical kind of immersed compute solution, which is all good stuff. So I think, you know, we've only covered a few topics here, but we've covered, you know, using renewable energy. We've covered doing EPDs and life cycle assessments of data centers. We've looked at the alternative uses for the heat, you know, trout farms, swimming pools, urban farming, lobster hatcheries, etc. We've looked even, you know, you're talking about your battery solution supported by renewable energy, CHP units, tri-generation. All of these technologies are out there right now for data centers to adopt. And all new data centers, I feel, should have some sort of planning requirement that they will use some sort of, you know, sustainable energy solutions moving forward. But it is a complex area, and you probably do need to get a specialist on board to help you where you can identify the local solutions. We've been talking to a number of organizations, which I can't really go into at the moment, but, you know, making campuses up where you've got all of these facilities on hand and you're basically just buying a building in which to put your data center in, and you're sharing services such as the power system, the backup generators, the security aspects, the handling of equipment coming in into it, you know. So it's more like a shopping mall approach to a data center than what we conventionally have. And, you know, I often feel that we are too focused on security, on the physical building. You know, you go to the Netherlands, and a lot of data centers have actually got their own moat around them, right? Okay, it's part of the fact that Netherlands is mostly underwater, so they need to get rid of the water somewhere and put it into moats, which is a nice urban environment. And you can use soft landscape and everything, and you've got all these security fences around there. Nobody's ever broken into a data center to steal data from a physical server. If you're going to steal data from a physical server, you'll do it at your desk using your black hat on and hack into there, right? So yeah, I get all of the security aspect, but it's so in the past. And I'm not suggesting that data centers should be, you know, not have fences up and not have CCTV and everything. But, you know, let's be realistic, right? We can prevent people from accessing the physical server itself by adopting the EN 5600 classes, class 1, class 2, class 3, class 4, and restricting entrance by keypads and security and everything. You know, we don't have to be over conscious for that. And I think that the industry also needs to become a little bit more collaborative. It needs to look outside of its boundary. It needs to talk to district heating companies. It needs to talk to the local community. It should ask them what they want. You know, we're going to have this big power hungry facility here. It's going to take 60 to 50 megawatts, even 100 megawatts. What can we do for you? You know, have you had problems with your power connection? Maybe we can have a microgrid and do all that sort of thing. So anyway, I've got a question.
There's no doubt, though, that that's going to be driven by, not by legislation, but by planning. You know,
Yeah.
the recent judgment at Google in Sweden was an excellent judgment. It actually said that they could have their 50 megawatts of generators, but they had to start looking at ways of reducing the carbon footprint of those generators, and they had to provide a plan to show how they were going to do that. They also had to have a plan for reusing the heat from the servers. So so in order for Google to build that data center, there were specific things they had to do to make that data center more climate positive. And that, I think, is a great example for other local authorities to, because again, as I say, it's a commercial organization and they won't do things unless they have to, and that's fair enough. Although Google, in fairness to them, have worked very hard to lower their carbon footprint. So I think legislation around permitting in places like Amsterdam and Frankfurt is already going ahead, and Dublin probably now, will help, and that's been forced upon them by the local electorate, that they have to do something with all of this heat that they have, and with all of this power that they're consuming, and all these standby generators belching out diesel smoke. So yeah, I think legislation will come out in time that every data center will have to be permitted to have all of these things included in their plan, you know, rather than wasting the heat and throwing away the diesel generators in terms of their emissions.
Yeah, so we've got a question from the panel. It says, what about emergency power supply? And I think this is quite an interesting topic as well. So currently, most data centers will have a backup power solution, which is primarily diesel generators. I think there is a data center to the west of London, actually, that's installing some gas turbines, which I think is an excellent idea. Not only because it's gas, so that's half the carbon footprint of conventional fuels or conventional sources of electricity, but also because those gas engines can be converted to run on green hydrogen at a later date. So I think it's a very forward-looking, obviously, data center designer. Perhaps he's been in one of my seminars in the past and has said, I don't want that John Booth knocking on my door and moaning at me, so I will adopt some of these solutions. And of course, emergency power also kind of links back to the resilience and the kind of very cautious nature of data centers. And, you know, it's quite interesting. I think it was Ian Bitterlin published something about 2 years ago. And he said, in this document, he said, and this was based on the 1986 combined central generating board. And it was the analysis of the outages that had happened in the UK power grid the previous year. And there had been, the average power outage in the UK was 11 seconds. The average. And the longest was 9 days. And that was because the substation blew up. Okay. So that's not bad going, actually, when you think about it, that it only took 9 days to replace a substation. So that if there was a data center hanging off of that substation, it would have been on diesel backup for 9 days, which would have meant, I don't know, probably 4 fuel deliveries in that time on a 3-day day rate. So my question there is, you know, and the UK grid has been quite stable. And I think we have a power factor of close to 0.99, which is as good as it can get, really. Are we getting a bit too precious about diesel generators if they're not being used?
Yes, I totally agree. I had a big run-in with the Uptime Institute when we were doing the Green Mountain data center, in fact, because the Green Mountain data center had 2 supplies coming to it from 2 diverse hydroelectric power stations. And the cables were diverse, and the whole thing was completely resilient. But the Uptime Institute insisted to get the Tier 3 certification that the generators were N+1, and also that the generators were rated for continuous rating. And I just didn't see the sense of that. You know, those grid supplies were as stable as you can get anywhere. But the Uptime Institute at the time was saying, well, it's the same rules that apply worldwide. Well, which is ridiculous. You know, you get a data center, no disrespect to Nigeria, but you get a data center in Nigeria, and I think it's more likely to have a few power failures than a data center in Norway. And so I think you're right. I think we should take into account the resilience of the grid in that particular area that the data center is being built, and decide then whether we need to have standby generators. The other thing you can do, of course, is you can actually shut down non-critical servers. If you just say you had a battery for an hour instead of a diesel generator, you could then, over that hour, you could automatically shut down non-critical servers and increase the autonomy time of the batteries. As the servers go down, the battery time increases. And we did one at Leeds University many years ago, and we went down from 200 kilowatts down to about 40 kilowatts over an hour's period. And so the autonomy of the battery was 4 or 5 hours, which was more than enough for any outage. So yeah, and obviously Google are looking very carefully at this at the moment in Belgium, aren't they? They're looking at ways to either not use diesel generators or use them powered by other things rather than diesel.
Well, I completely agree with you, John. I've always had a bit of an issue about data centers, you know, running continuously on backup generation, because to my mind, they're providing a service. If you say, for instance, oh, he's gone. Okay, are you still there, John?
Yeah, I just got to do something.
Okay, so when I was an IT technician and I was working installing servers and everything, and we used to put rack-mounted UPS systems actually in the bottom of the racks, and they used to have a cable that ran from the UPS up to the server itself. And if the power was lost to the room, that rack-mounted UPS would trigger a script that shut down the server gracefully. Okay, and I've always had an issue, because if you have a power cut in your building and you keep the data center up with a backup generator, etc., who are you providing the services for? Because the rest of the people in that building cannot access their data because all their computers have gone down and they're on emergency lighting. So I've never understood that concept of having to have backup power continuously running to keep those services up, because your users can't access the data. And you know, I think that then starts to make sense. I mean, is that a big fallacy in the whole of the industry, that actually our backup power is there to provide continuous service, or is it merely to allow each of the servers that we have to recognize that they are in a UPS situation and to gracefully shut down, therefore not losing any data? What's your thoughts on that?
Yeah, I mean, as you say, there's no logic in it really, because half the time no one can access the data center if all of the security data and on the UPS or on the generators and video cameras and all that sort of thing. So it's a really interesting point that you make there, and I think we both agree that tracking them down sequentially is, and or transferring the data to other sites, which is what Google do, of course. The resilience they have relies on multiple locations rather than on one data center. And so yeah.
And the other thing is, you know, look at some of the standards that relate to data centers, and they talk about diverse cabling, right? So your power feeds coming into your building should come from, well, effectively they say, if you look deep into the standard, it just says you should have a diverse route from the outside your data center boundary. And I remember getting into quite a heated argument with somebody who told me that his data center was EN 5600 compliant because his ducts were 20 meters away from each other. Right? And I said to him, but where do they go after that? And he says, well, they feed into the same external duct and it goes off to the same substation. I said, so what's the point? What's the point? And I think, you know, there is a lot of fallacy and myths and rumors, and people will say black is white and white is black. When really they need to understand exactly what it is. You know, having a diverse power supply that goes back to the same substation is no proof of your data center being resilient at all.
And the other vulnerability is the fiber routes, of course, which you could talk about for hours.
Absolutely, you'll probably find that unless you happen to be on the boundary of one BT exchange and another BT exchange, that your fiber will be going back to the same exchange. And if there's a fire at that exchange, then you're off air. It's as simple as that. So we've got another two questions actually. So we've got, do we still need backup power with a distributed architecture? And I think myself and John would agree that no, you don't. And in fact, if you look at the cloud, the way that the cloud's architected with 2 availability zones in most countries, there's even an argument to say that those data centers don't need to be tier 4 or class 4. They could easily be tier 1, albeit a big tier 1. And you don't need to worry, especially with continuous access. So your data that you're writing in the cloud is going to 2 separate data centers and be installed in 2 separate storage systems. Yeah, I would say we don't need backup power, right? And as the goes on to say, so the data center is no longer the critical element, it just gets taken over by another data center. And I think we both agree with that. But there is sometimes a delay and lag. And what happens if you have 2 availability zones and one is in failure mode and then the other one fails? Then you've got to look at your network architecture and your architecture of that particular area with a little bit more kind of focus on it. But we need to look at.
I'm just questioning you, who you're trying to influence, though. Who is it that tells us that we have to have standby generators and they have to be N+1 and they have to be continuously rated and all these things? I mean, who do we try and influence to stop that? Is it the client, or is it the consultant working for the client? You know, because those are the people who drive these things, aren't they, in terms of co-location space? You know?
Well, that, John, is a very interesting question, and one I think that we should have in Monaco, quaffing a very good bottle of wine that you're going to pay for on one of the beaches. And we can invite somebody from the C-suite that go to Monaco and ask them the question, right? Where do they get these design criteria from? And I would tend to agree. I think that a lot of the data center myths, urban myths and construction requirements that happen today are something from the 20th century. And I've been calling this for a while now, but I think the whole industry needs a radical rethink about how it delivers ICT services. And that goes from the server manufacturers all the way to the data center providers, and probably links in with the network guys as well. You know, I can never understand why a server that has a 240 volt AC power supply, and yet inside the board itself operates on plus and minus 3 volts, 5 volts and 12 volts DC. Right? So why are we, you know, what are the 2 main heat sources in the server? The chips and the power supply. The chips, you know, that's just the fact of the way that the chip's architected. The power supply, on the other hand, that's because it's generating heat, because it's taking 240 volts to 220 volts AC in, stepping it down to those micro voltages on the board. And that's not the only transformer in the chain. You think about the entire power chain, power station, wherever it is, steps it up 400 volts, goes to the transmission line, even higher up there, you know, thousands of volts, gets to where it's going, drops down again. And then we might have a substation and another transformer in line. So the voltage is getting stepped up and stepped down multiple times from the power station to the server itself. And this is why, if you do the analysis, only something less than 0.5% of the power generated at the power station actually does useful work on the server.
Yeah. Can I just come in here with my plug for immersion cooling, which is another interesting passion of mine?
Yes.
Because in that instance, what you're doing is you disconnect the fans on the servers to immerse them in a non-conductive liquid bath. And by disconnecting the fans, you actually reduce the power demand by 10 to 15%. because that's how much power the fans take to cool the servers. And the actual power you need to run the immersion cooling solution is only that 10 to 15%, and the rest of the H&V load disappears. So to me, immersion cooling has to be the way forward for data centers, apart from the fact it uses a lot less space, so it's a lower carbon footprint, and can be reused the heat from the servers more easily. I think that is a really interesting statistic, and one that more and more people should take on board. And that's the way I think the industry will eventually go, even though I've been plugging away at it for a few years and I still haven't got enough customers yet on immersion cooling to talk about anything sensible. But I think with the sustainability agenda coming to the fore now, I think it's going to happen.
I would absolutely agree with you. I think it's almost inevitable. I think we're going to have to see a big shake-up in data centers, and it'll probably be triggered by the Commission with their Green Deal and partly for that climate neutral data center Pact. And I think some of the targets that are inside the Pact will probably be reduced as part of the Commission's deal to say, well, who knows? You know, at the moment there's the climate neutral data center Pact is self-regulatory, and some would argue that it was just another attempt by the industry to kick the compliance can down the road a little bit longer. And that's a fair point. But I think that the commissioners have seen they're a bit wise to that, and I don't think they're going to. I don't think they're going to let it fly, to be honest. But I am party to some interesting information, which I obviously can't divulge at the moment. But it'll be interesting to see how it reacts.
It might for part 3, will we, John?
I think we probably will when we say when we discuss how it's happened. We've got another question actually. So Alex said, so we can power the data center direct from solar DC on the roof. It's not that simple. I was discussing this last week with an actual data center designer, and he said the size of the copper cable needed to get the DC from the roof to the data center to the actual server itself is kind of like the size of a tree trunk. But I'm pretty sure we can engineer our way out of that one. And then I think Dan Holzman said, good point about the power chain, but distributing low voltage, high current lines over distance becomes ineffective due to voltage drops unless you have zero resistance wires. And I would agree with that as well, but I'm not looking to take power from power stations conventionally for our data center. So I'm looking at using local microgrids and potentially hydrogen fuel cells. So I think the step up, step down kind of disappears. As I said, this is just me kind of, sitting there with a glass of wine and just shooting off. Somebody needs to do some studies on it. And I think we'll get there eventually. Margaret, can I ask you to pop in, please? Because we've kind of run out of stuff to think about, and we've got 7 minutes left, but we're open until 9 o'clock, till 7 o'clock. So I don't know how I'm going to keep going for another half an hour, because I think myself and John have kind of explored everything.
Yeah, we certainly have. All the things in my agenda have been covered, I think.
Could actually, apart from actually thanking you both very much, because it's been really interesting. And can I do a little bit of a plug, please? If you could unshare, John.
I certainly can.
That would be fantastic. Because one of the things actually I was thinking about is that we have certain competitions coming up that would like to sort of actually just bring to people's attention. If I can actually share my screen and hopefully share the right thing, which I hope is the right one for the competitions. Can I just actually draw people's attention to it? Because coming up to the end of June, which is remarkably close, we have a series of competitions. And these are for students and also for BCS members as open plan. Now, we have particularly a green, I'll give you an example of those in a moment, but there is a Green IT PowerPoint competition. And this is how computing could help the Earth. Oops, I've just realised I've got an awful lot of these. Shows the impact I was thinking about the Earth, so maybe I ought to remove that one, an extra one. And if you go to this link, what you're looking for here is some way that primary schools could enter and right up to the postgraduate and open class. Now the open is for BCS members or a team of adults, of which one is a BCS member. So you need to have one to be a BCS member, and you've got all the details there. For the schools, they are you need a point of contact. In other words, we don't want to deal directly with any children for obvious reasons. So it's run through a member of the staff from the education, from the school, from the university, etc. There is an e-learning competition about how e-learning could use to assist the society environment, and that also has a very green influence because it could be using e-learning to make people much more aware. There is a similar one for animation and games, and that's how to make people happier. But if I can give you an example of a previous winner. So I'm just using this to try to encourage any last minute entries. Now, a few years ago, we had sorry, an entry from a young lady at a university, single PowerPoint. It could have been entered in the computer games. It could equally have been entered, in fact, in the e-learning, or it could have been entered, in fact, in the Green IT competition. There was just a very simple picture. So if you're doing a PowerPoint, just a picture that draws, it could be hand drawn as long as you scan it and put it in your PowerPoint. And she called this the Last Mermaid. And if you think about a mermaid sitting on a rock surrounded by absolutely filthy rubbish in the sea all around. So the picture immediately told the story of what this whole idea was about. And there was about 5 bullet points, and that explained that it was a simple computer game, all ages, and compare the different times that you could actually use to get rid of things from an apple core to a baby's nappy. And you could actually come up to the higher level of the game about which sort of wildlife are damaged by which sort of products, etc. So this actually could have been and entered for the Green IT competition just as easily as the games, because it raised awareness of basically helping the Earth. And all the judges were equally enthusiastic that this had to be the winner. And what they were looking for, there's no criterion, a suitable picture that tells a story, and a few bullet points that explain what it's all about. So, as I said, this could have been for the Green IT. Now, our Green IT competition this year is how computing could help the Earth. So again, you could come up with simpler ways, different ways of using turbines in the big or even down into the micro. Maybe the idea is you have a little turbine on your fixed on your hat if it's a hot weather to actually give you air conditioning. So you never know, that could be the solution. So there's all sorts of other variations of how you can have a hybrid car, but why do they have to be conventional hybrid with petrol and electricity? Maybe there's another way you can self-generate the electricity while you're actually going along and driving along, maybe suitable particularly for long distance lorries on motorways. So there's lots of possibilities and very keen to encourage it. So just to give you a little feel of what we've actually got. So I'd like to just stop that and encourage people to have a think about it. And I'm sure there's lots of people here with children in primary, secondary, FE, university. So I've done my little plug. There's also, as John mentioned, on Wednesday, we have 2 events, one in the afternoon and one in the evening.
Thank you, Margaret. I've got, I'm sorry to butt in, but we've got a question from Andy Matari, John. What is the carbon footprint of a data center per server? And what is the carbon footprint of an IT organization per employee? I think John would agree with me is that it could range, it really depends on the scope of the organization. What I can tell you is that a conventional server in a data center costs around £14,000 per year to run. but that includes the initial purchase cost for the first year. No, in fact, it doesn't. It's £14,000 per year. It includes the energy costs and the IT servicing costs and a percentage of the embodied carbon of itself and the percentage of embodied carbon for the M&E, the actual data center itself. And there is actually some very strict guidance on how you calculate the carbon footprint of a service, various services from an ICT perspective. But I would say that none of them have been adequately tested as yet. And because of that, we don't really have a good idea. Now, what you'll find is that there are two elements to a server in terms of its carbon footprint. There is something called embodied carbon, which is all of the energy used in manufacturing. And that then links into all of the raw materials, the processing of the raw materials, the transportation of raw materials, the assembly of those raw materials into or processed goods into a server, and then its final delivery at a distribution depot, and then potentially some transport from there to your site. And that will be a significant amount of embedded carbon, significant. Around about 15% of the overall embedded carbon of that server. Then you plug it in and turn it on. And that really is an open-ended carbon footprint, because that depends on a number of factors: where you're located, the PUE of your data center, and how long it's in there for. So if it's in there for 5 years, it will have a certain amount. If it's in there for 10 years, it will have another amount. So unless you know exactly what it is, it's very difficult to calculate the overall total carbon footprint of a server. We can get the first bit relatively simply. Well, I say simply, I've been doing it, and it's not that simple. It's quite hard. But you can get there. It will take you about a week to find out the information if you're going to go into that much detail. And from a perspective of from the employee, what is the carbon footprint of an IT organization per employee? Again, it's difficult to quantify, because you have to you can't just come off with a figure, because it will be different depending on which type of organization. Just a straightforward IT services organization would be relatively easy, but then it would be difficult to then go and ascertain what Amazon's or Google's IT carbon footprint is, because they probably don't know themselves, to be honest. And I think that's where we are at the moment. Not many people know the full extent of it, and some people don't even want to publish it because they would treat that as being commercial in confidence. So, but it's all in embryonic stuff, and it's very exciting, because I think that excuse me, there's going to be a lot of people that are going to have to start calculating that, especially in terms of the carbon reduction plan, the PPN 0621, which I mentioned earlier in the show, and because I think governments are going to demand it. And here's my thoughts on this, and John, feel free to comment afterwards. The data center industry, green IT itself, has two major functions. The first function is to green itself. So we should be, straining tooth and sinew to reduce the embodied carbon and operational carbon of ITC systems per se. And we should also be looking actively to how we use IT to reduce carbon emissions elsewhere in society. So, for instance, a couple of examples of that. This event we're doing now, we're doing it, from our homes. We could have done it live in the British Computer Society headquarters in London. That would have negated 30 odd people traveling to that site. We'd have had that site's embodied carbon energy, the lighting of that site, any presentations you wanted to give, plus the transport energy of getting those 22 people here. And it'd be interesting to basically compare that against what it's costing us now. So we have 33 people on call using their own IT energy in the house, plus the Zoom platform, or wherever it happens to be. And it could be that it's kind of equal. But we don't do that just because of the energy consumption. We're doing it for other reasons, such as the pandemic and the risk of getting captured. So it's not going to be simple, but I don't think that anybody expects the IT industry to get a free pass in determining its carbon footprinting and its need to become more net zero. I don't think that's going to happen. The steel guys and the concrete manufacturers would argue that, they've done some great things. So we've got hollow core concrete. I was watching how it's made actually. And in the Netherlands, they put rubber balls into the concrete, which reduces the total amount of concrete by 50%. And it maintains its structural strength. These are innovative solutions. Steel guys, we know that steel is, in order to make steel, you have to get up to 1300 degrees C. You ain't going to get that with wind farms, but green hydrogen you can. So we know that there's a steel mill in Sweden that's experimenting with green hydrogen to get those steel temperatures up, right? So these are already around there. I don't think the world is going to give data centers and the ICT industry a free pass.
I agree. The one point I would make there, an interesting company called IT Renew. Every 2 years, the big hyperscalers renew their OCP, Open Compute Project servers. And IT Renew take those servers and they refurbish them and reuse them. And that's got a dramatic reduction in the carbon footprint of that server compared to manufacturing a new one. And I think there must be more and more reason to recycle. There are other companies doing it. There's a company in Scotland doing it with servers. But that's got to be the way forward in terms of reducing the carbon footprint of the manufacturing of the servers in the first place.
And of course, on that note, we've had some, I think it's recent French legislation that talks about the right to repair.
Okay.
So a lot of ICT equipment, it's not easy to repair. Especially some of the newer stuff, the smartphones, the products of a certain fruit. It's very difficult to repair those ones. But will that mean that the French turn around and say, "Hey, sorry, mate, you can't sell any of your products here because they not repairable," or will it force that company to start thinking about whether or not those items can be repaired in a specialist shop? And I know that people do screen replacements for them, which are not, official. So there's that element to it. And there was one other element which I was just thinking of. It will come to me in a moment. Yeah, I was actually sitting on a US standards body, Energy Star 3 for servers, as an observer, and I saw the draft Energy Star 3 specification for a standard, and there was a great deal of recycling in the original document. It was up near 85%, and the hardware manufacturers pushed back on that, pushed back on it really, really hard, and said, "No, we can't do it. We absolutely can't do it."
They would, wouldn't they?
Absolutely. And there was a bit of to and fro-ing, and it ultimately ended up about 35%, and that's a big reduction. Right. So, and this is why I say that the industry needs to look at itself, because we know that there's some stuff out there we could be doing.
I guess at the end of the day, it'll be driven by consumers, won't it? That's the point.
Well, you say that, but I think consumers, but unfortunately, the smartphone genie is out of the bottle. Everybody. I mean, my contract is a 2-year contract, and it finished in December, and I haven't renewed. I haven't got a new phone. I could get a new phone, but I haven't got a new phone. This phone I've got is perfectly adequate. Does what it needs to say on the tin. It's good. But I think the recent announcement from Microsoft, like Windows 11, right? And it's a free download, right? As when it's finally published, it'll be a free download. And you'll find that most Windows 10, it will become part of it. It will be a service update. Right? You and I both know that that software will push between 10 and 20% of current PCs running Windows 10, and it won't be able to operate on them. Right? It will not operate. Simple as that. You know, you need 4 gig, I think it's minimum, and an 8 gig disk to run it, and that's going to stop all of those other potential.
That's a good point. That's a good point.
Right, and yeah, Microsoft is going to tell everybody they're going to be carbon neutral, historically carbon neutral as well. That's because they're pushing all of their end emissions onto the user. Yeah, right. Yeah. So you know, there's a lot of there's some politics that need to be invoked as well, I think, into this big debate. You know, we can't have you know, John, we're going to go down a different road, and we're talking about data centers. We're not talking about a wider green IT aspect, but does need to have some green IT aspects need to be thought about in this. Yeah. And at the moment, we're you know, we need to sort something out. I mean, Mike Barnes has just just put 2 statements in. So the first one is re-backup power and no need as data center to swap to another data center. Yeah, we've already discussed that. And then he talks about was there not a massive outage some weeks ago and the site went down for some time. He's talking about Flappily or something.
Yeah, the site in the States. Yeah.
Yeah. And I think that brings me on to another topic.
Somebody's right. Fastly. Yeah.
Fastly, yeah. It comes on to another topic, which is data centers and ICT is not considered a utility, right? BT, telecommunications, was utility. The government of the day decided back in the 80s that actually it could be more open to competition, and that's fine. But, you know, that's a long time ago. And I have to say that today, Fastly being an absolutely fantastic example of, is there a case that data centers and ICT systems be treated as a utility and therefore regulated a little bit higher than they are now? And that would mean strict processes and procedures to doing and making changes, because that Fastly guy, that was a config error made by one of their CDN networks and one data center which cascaded round. Right? It's an absolutely fascinating discussion. But it's a little bit more wide-ranging than I think being on the London Climate Action Week, and probably a topic for later discussion by the BCS at some point in the future. Anyway, it's 6:45. We've got about 15 minutes left. Is there any more questions? Okay. I don't think so. Right, so thank you. That's been a BCS Green IT Specialist Group webinar. Myself, John Booth, the Vice Chair of the Green IT SG, and Jonathan Evans from Total Data Center Solutions, and our wonderful host Margaret Ross, as part of the London Climate Action Week. There is another event taking place on the 30th, which is I did have it up there. It's gone now. Right. Okay. Which is something else to do with Green IT. So just look it up on the old website. It's on both websites. It's on the Green IT website. It's on the BCS events page, and that's where I'm going to go now because I'm conscious. Yeah, it's climate, environment, sustainability, key issues for the UK tech sector, which is Suzanne Baker who's the Associate Director of Climate, Environment and Sustainability at Tech UK, and Margot King, who's a Master's Environmental Technology student at Imperial College London. And the synopsis of the event is, what are the material sustainability issues impacting the tech sector, and how are the tech sector, government and society responding? How can tech help with sustainabilities in other sectors, which is what we've been talking about earlier on today. And they will consider some of the latest policy developments, tech sustainability trends, and the challenges that remain to be resolved. Yep. Okay, and you can find that out on our website, the BCS events website, and it's on the 30th of June. And I believe it's also on the London Climate Action Week website.
Okay, well, great. Thanks for inviting me, Margaret and John, to join you in this presentation. I really found it very interesting. And hope to catch up again soon.
Okay, so can I thank you both very much, and both Johns, really. It was fantastic. And I'll stop the recording now. Hopefully. Anyway, thank you all very much. And I'd like to say thank you.
Okay, bye-bye.
Bye.
Bye-bye, Margaret. Bye-bye, John.
Bye-bye, thank you.
Bye.